Have you ever thought about the possibility that right now, as you sit there listening to me, your planet might be the only one in the whole universe where people have started living together in cities and towns? The odds of this happening are 1 in 10 trillion. That's almost as improbable as randomly grabbing a handful of sand in the Sahara and finding the 1 grain of gold, while the rest of that boundless sea of sand remains utterly lifeless. Today, we're going to explore this scary topic. We'll take you from the poor areas of our galaxy to the farthest reaches of space. By the end, you'll understand the hopeless situation behind the Fermi Paradox and think about what it means to be human. In reality, every star in that thick, glittering blanket of stars we see every night is a small version of a star that is very bright, either a burning stellar body like our own sun, or a giant rock that reflects light like our moon. Think about this. Our sun is as common as a random person on a busy city street among the 400 billion stars of the Milky Way. Even more disheartening is the data from the Hubble telescope within the observable universe. There are a staggering 2 trillion galaxies like our own Milky Way. In 1950, Enrico Fermi, a physicist, was amazed by this huge number. He asked himself, what does this mean? If there are extraterrestrials, where are they? This question later became known as the Fermi Paradox, an unsolved mystery in cosmology. Let's do the math. The universe is about 13.8 billion years old, while our solar system has only been around for 4.6 billion years. If one advanced civilization had set out billions of years before us, they should have already conquered the entire Milky Way. But the truth is, the Milky Way is still very quiet. We haven't received any radio signals from aliens. To find out if there are really other planets in our galaxy, a scientist named Drake created a formula called the Drake equation in 1961. He tried to think about different things like how many stars there are, the number of planets, and the odds of life, starting to figure out how many civilizations might be out there in our galaxy. At first, everyone was hopeful. There must be thousands, or even tens of thousands, of them. But the more we looked into it, the more we realized that this optimism was not realistic. Let's start by looking at the bigger picture, the galaxy's environment. The Milky Way isn't all the same. It has its own version of prime real estate and slums. If you're too close to the middle of the galaxy, there are a lot of stars. It's like the cosmic equivalent of a busy downtown area, but filled with deadly radiation. There's also a giant black hole at the center, making it almost impossible to live there. But if you live too close to the edge, heavy metal elements become scarce. This makes it difficult for rocky planets like Earth to form. Scientists estimate that the truly habitable zone in the Milky Way, where life could take root, covers only about 10% of its total area. And get this, our sun is in an amazing spot, 26,000 light-years from the center of the galaxy. This alone makes it very unlikely that life could exist there. If we look at the whole universe, we see that galaxies can be different sizes. Many galaxies with strange shapes simply cannot support life. Only beautiful spiral galaxies like our Milky Way are relatively ideal. In the observable universe, these top-tier galaxies make up just 10%. The probability goes from 10% to 1%. And the best galaxies, like the Milky Way, which are found in the outer parts of the universe, account for only 1/10 of that 1%. That makes the odds 0.1%. Think that's it. We're just getting started. Even if you have a good galaxy, you still need the right spot around the star, the so-called habitable zone. Here, planets can't be too cold or too hot. Liquid water must exist. If you get too close, it will be like a hellish version of Venus, where even lead would melt. If you go too far, you end up like Jupiter's moons, colder than a freezer. Earth is located between the Sun and its orbit, with a distance of 150 million kilometers. This habitable zone covers only 10% of the star system, which makes the odds of life there 1 in 10,000. Stars aren't static. They expand, they age, and the position of the habitable zone shifts accordingly. Staying stable within the habitable zone for billions of years is as difficult as climbing to the heavens. Our Sun is a medium-mass star. It is the right size. Massive stars don't live very long. They explode as supernovas within tens of millions of years. This doesn't give the planets around them time to evolve life. Smaller red dwarfs may live longer, but they frequently emit radiation flares that can instantly strip away a planet's atmosphere. Beyond these factors, Earth has an exceptionally unique guardian. The Moon. The quiet climate we have now is all because of the Moon's role in keeping Earth's axis stable. Without the Moon, Earth's climate would be very unstable. Life on Earth would not have time to adapt before it disappeared. The Moon's gravitational pull has also made Earth rotate more slowly. Otherwise, our days might last only 8 hours. With surface winds reaching 300 kilometers per hour, a very unpleasant experience. This is a very rare celestial pairing. Similar to the Earth and the Moon, only about 10% of habitable planets are thought to have a satellite like that. This doesn't even take into account Earth's unique magnetic field, atmosphere, perfectly balanced crustal movements, and protective shield against solar winds. When all these conditions come together, the probability of life emerging is extremely low. The universe has more planets than there are grains of sand in the sky, about 10 of them. But if we multiply that number by the very small chance of finding a habitable world, we see that there are very few of them. We need to change the question. Maybe aliens aren't ignoring us. Maybe we are the only survivors in the universe. This blue planet isn't just our home, it's likely the only sign of civilization in the cold, vast cosmos. Some people might say that life should naturally emerge if the environment and water are just right. But there's a big difference between these conditions. Water is like the stage for a play. To have a play, we need a script and actors. The script of life is a term for how elements like carbon, hydrogen, oxygen, and nitrogen work together to make complex organic molecules. These molecules must come together to form amino acids and nucleotides, and then fold into DNA and proteins. It's really hard to put together the building blocks of life. Scientists are studying the early Earth in labs. They use electricity, heating, and a lot of effort to make molecules. But so far, they have only made simple molecules. In the real universe, this process likely took billions of years of random collisions. Even if life somehow started, it would face many risks of dying out. The Earth's early magnetic field and atmosphere worked like natural bulletproof vests, protecting it from deadly cosmic radiation and the constant flow of asteroids. If there was no barrier, these tiny organisms would have been destroyed before they could even grow. Even more astonishing is the evolution from simple life to intelligent beings, a huge gamble that lasted for millions of years. Earth's earliest life emerged 3.5 billion years ago, yet humanity didn't appear until millions of years ago. Over 4 billion years, what transformations has life undergone? It is a wondrous process. From simple cells to complex organisms, from water to land. Every step in evolution was like walking a tightrope over a huge chasm. If the dice had rolled just one more time differently, Earth might still be ruled by bacteria. Some scholars even suggest a strange idea. As civilizations become more advanced, they also become more dangerous. Think about how far technology has come. We've created nuclear weapons and artificial intelligence, but we've also caused pollution and uncertainty. This phenomenon is known as the Great Filter Theory. The theory suggests that life must deal with many critical moments on its evolutionary path. Some life forms died during the transition from single-cell to multicellular organisms, while others lost the ability to become intelligent. It seems that humans may be among the rare fortunate few who have yet to be filtered out. But this also means that the next great filter might be right around the corner, waiting to happen. We also have to think about this. What if aliens are sending signals, but we can't hear them? It's like someone living in ancient times who could never understand radio. We're looking for radio waves in space. But there's a chance that advanced civilizations are already using things we don't understand, like neutrino communication or quantum entanglement. It's like us trying to find signals with an old radio while they're sending satellite broadband. We're just not on the same frequency. Perhaps we are not alone. It's just that we are so far behind that they simply don't care about us. It's like you wouldn't stop to explain the internet to an aunt. At this point, you might feel a bit confused. You might want to find companionship in this vast universe, but you're also afraid that you might attract unwelcome visitors. This brings us to the dark forest theory, which is well known among science fiction fans. This idea is that the universe is like a dark forest where every civilization is a hunter with a gun. Because we can't really trust each other, and we don't know what the others are up to, it's best to stay hidden. The first person to reveal their position risks being eliminated. This is why some scientists strongly oppose humanity broadcasting locational signals into deep space. If we attract neighbors who are not kind, but dangerous, our small planet could be in big trouble. However, there's also a group that is hopeful. They believe that if a civilization truly evolves to the point of interstellar travel, it likely moves beyond the basic resource-based economy and enters a higher stage of civilization. According to the classification of civilizations, a Type 1 civilization can fully harness its planet's energy. This gives them the ability to trigger earthquakes or calm tsunamis at will. Humankind hasn't reached this level yet. We're only at 0.7. Type 2 civilizations can harness entire stars, treating their suns as personal power stations. Type 3 civilizations are even more extraordinary. They can manipulate the energy of entire galaxies at will. If there are civilizations like this, we might seem like a pretty patch of wildflowers to them. Some scientists suggest that other civilizations in space may have found us a long time ago, but are keeping that information secret. They think these civilizations are watching us evolve, much like how we study monkeys in protected areas. They don't get involved or talk to us. They just watch what we're doing. When talking about taming stars, you have to mention the amazing engineering feat known as the Dyson sphere. Picture a huge, round shell around a star that captures all of the star's energy for the people to use. If we ever see a star getting suddenly fainter and brighter, it could mean that an advanced civilization is building a structure like that. Scientists have indeed looked for these signals. Take the star KIC 8,462,852, for example. A few years ago, it was very bright, but then it dimmed suddenly. We couldn't confirm it was a Dyson sphere, but this shows us that there are mysteries in the universe that we can't imagine. Talking about advanced civilizations, let's think about how humans might leave Earth in the future. Using chemical rockets is clearly not enough. They are as slow as a turtle on a cosmic scale. Voyager 1 has been traveling for almost 50 years and is still going strong, still orbiting the Sun. To achieve true interstellar travel, we'll need technologies that sound like something out of science fiction. Take nuclear fusion engines, for instance. They essentially pack miniature stars into spacecraft. Another option is antimatter propulsion. A single gram of antimatter could unleash energy equivalent to the energy released by the atomic bomb dropped on Hiroshima. That's true speed and excitement. If we dare to dream even bigger, we could explore warp drives that bend spacetime like paper instead of racing through it. Or look for legendary wormholes like the subway entrances of the cosmos that can take you to other galaxies right away. These ideas may sound like mystical theories, but they are actually based on solid scientific principles. From Einstein's theory of relativity to later models of multidimensional space, these dreams are supported by theoretical frameworks. Our constant desire to explore isn't just about curiosity. To be honest, Earth may seem fine now, but it isn't immortal. Beyond immediate concerns like climate change and running out of resources, the Sun itself will grow old billions of years from now. It will expand into a red giant that will swallow Earth whole. In the future, the whole universe may end. This could happen when all stars go out, or when dark energy destroys all matter. So, cosmic migration isn't just some romantic adventure, it's something our species needs to survive. Our current top choice is Mars. Even though the environment is very cold, it is still relatively close. If we ever figure out how to travel to other planets, places like Kepler 4.5b, which look a lot like Earth, could become our new home. But with our current technology, the trip could take tens of thousands of years. Right now, our top priority is protecting our home planet. Don't think that choosing another world is easy. Finding a place in this vast universe where you can breathe is harder than winning the lottery jackpot. To understand this fully, we need to look more closely at the important conditions that allowed life to appear. Did you know that the universe made a lot of small changes to make life possible on this planet? First, if the amount of oxygen in the air was a little higher, forests would be filled with fire. If it were lower, complex brain activity wouldn't be possible. This balance, exact to the decimal point, has been kept on Earth for hundreds of millions of years. Even more interesting is that Earth's magnetic field isn't just for pointing north and south. It acts like an invisible, powerful shield, blocking the stream of charged particles ejected by the sun. If there weren't a magnetic field, the solar wind would sweep away Earth's atmosphere like a giant broom, leaving it barren and desolate like Mars. The magnetic field comes from Earth's core, which is made of iron and nickel and spins all the time. For this core to keep spinning, Earth had to get enough heat during its formation and cool down at just the right rate. It's as if someone with perfect knowledge of the future had carefully adjusted every detail. We should talk about how it seems like there's no hope for figuring out where life came from. Even in labs, scientists haven't been able to make the most basic living cell. Life is more than just a bunch of chemicals. It's like a really complicated system that organizes itself. The change from inorganic matter, for example, rocks and minerals to organic compounds, for example, plants and animals, and then to self-replicating genetic material, the instructions for life, is like throwing a bunch of parts into a warehouse and expecting a tornado to come through and automatically put them together to make a Boeing 747. The universe has a lot of time to try, but it's very unlikely that any attempt will succeed on any single planet. It's important to understand that the development of human civilization was largely unexpected. Dinosaurs were the dominant animals on Earth for over 100 million years. They were powerful and fierce, but they never became a civilized society like ours. If a 10-kilometer space rock hadn't hit the Gulf of Mexico, ending the age of dinosaurs and allowing mammals to thrive, Earth might still be ruled by giant lizards. In other words, even after life emerges, it evolves toward intelligence because of a series of very lucky external events. A really interesting question is, if aliens really exist, why haven't they contacted us? One big problem is how big the universe is. Even if you could travel at the speed of light, crossing the Milky Way would take 100,000 years. For any carbon-based life form, the amount of time they live is limited. Without breaking the speed of light, traveling between stars becomes a project that spans many generations. This could be very difficult for society and the environment. Maybe there are many civilizations in space, but they don't know about each other. They are curious about each other, but they are very different. Or let's think about something even more exciting. Maybe aliens haven't failed to visit us, they've simply changed into forms that we can't understand. Maybe civilizations, once they've reached a certain level of development, choose to leave their physical bodies behind. They could upload their consciousness into computers or even shrink themselves to the atomic level. For them, exploring the universe might seem boring compared to the endless possibilities of creating things in tiny virtual spaces. These beings could be living right beside us, but we can't see them because our senses are limited. When thinking about how lonely humans are in the universe, we need to think about it in the biggest way. Could there be another universe that's very similar to our own? Welcome to the theory of the multiverse. This isn't a Marvel setting. It's a real idea in physics. Some scientists suggest that our universe might be just one bubble among many. Each bubble is like its own world. It has its own physical constants, dimensional structure, and even the rate at which time flows. So, we have to ask, if there are many universes, could another Earth or another version of you be in one of them? The answer is yes, it's possible. According to the many worlds interpretation of quantum mechanics, every quantum event causes the universe to branch into different possibilities. Eating that bowl of noodles today might create two parallel universes. That might sound a little crazy, but it's true. However, this theory explains some things better than traditional quantum theory. You might wonder if we can travel between them. Scientists are looking for evidence that our universe may have collided with another. They are searching for traces of cosmic collisions, like unusual cold spots in cosmic background radiation. These cold spots are like ripples left when two bubbles collide. If these theories are true, we aren't the only life in the universe, but we are the only ones in this version. Scientists say there are three possible endings for the universe. The first is heat death. The universe keeps expanding, growing colder and colder until stars go out, energy runs out, and everything becomes a dead, frozen refrigerator. The second is the Big Rip. If dark energy grows stronger, it might eventually tear apart galaxies, planets, and even atoms. The third is the Big Crunch. If gravity ultimately overpowers expansion, the universe would snap back like a spring, returning everything to its starting point for a reboot. In other words, the universe will either freeze, explode, or restart. None of these endings are perfect. You might say, that's billions of years from now. Why should I care? But the big question is still, can we find a way to escape before the universe ends? Some scientists imagine that they could save all of human knowledge by turning it into digital data and sending it to special machines called von Neumann probes. These probes would then be able to travel to other galaxies. Or, we could create a second home while the universe is still hot. Some people even suggest creating artificial wormholes for interdimensional travel, which would allow for true cosmic escape. Some people even suggest creating artificial wormholes for interdimensional travel, which would allow for true cosmic escape. Human technology is truly moving forward in this area. For example, both the US and China are researching nuclear-powered spacecraft. Quantum communication has been tested on satellites. The European Future Telescope project is looking for exoplanets that are similar to Earth. China is speeding up space manufacturing to get ready for people to live in space for a long time. Even more distant futures have wilder concepts. One example is consciousness uploading, which would scan human brains into data, allowing existence in the cloud. The simulated universe hypothesis suggests that our reality might be a cosmic simulator built by an advanced civilization. We could be running a storyline within a supercomputer. These ideas may sound like something from science fiction, but they're based on theories in physics, astronomy, and information science that are very advanced for their time. One day, they might not be just a fantasy. Think about this. Even though humans may seem like a tiny speck of dust in the universe, our minds can travel billions of light years to explore new frontiers. This is the most important part of our lives as smart beings. Finally, let's look back at Earth. This planet is unique because it's the only one known to have life that can ask questions. On this planet, curiosity, language, and art were born. So, stop saying Earth is just a small planet. It's a miracle that was created over billions of years. Stop wondering where the aliens are. Maybe we are the first civilization to arrive here. We are not just onlookers. We are the beginning of a very long story. Protecting Earth means protecting the rarest thinking planet in the universe. You are standing on this planet, looking up at the future of the universe. To sum up what we talked about today, it's clear that the fact that Earth can produce humans is a truly amazing thing. Everything in the universe seems to be working against us. In this vast and empty universe, the fact that our small flame of civilization has burned for millions of years is something that makes all of humanity proud. If you find this idea unlikely, please give it a thumbs up. What do you think about whether there are aliens in the universe? Do you think we are truly alone, or are the hunters just hiding? Please share your thoughts in the comments section. If you want to know more about the mysteries of the cosmos and the evolution of civilization, subscribe to my channel. Let's explore the vast universe of stars together. The universe may be cold, but human curiosity is warm. Thank you for joining me. I'll see you in the next video.